Hey guys, welcome back to my YouTube channel. So here we are going to continue our discussion on the K-map. So the last class we have detailed discuss about two variable K-map. I hope you guys able to understand how to find the min term, max term. From that how we can simplify the Boolean algebra. That also we have discussed carefully. So now let's get into three variable K-map and then more into discussion. So first let me discuss how we can write the two variable K-maps. Okay. So here there is two possibilities. We can write as it is three variable. We can take any kind of things into our decision. So we are splitting this into 2, I'm splitting this into 6, I'm splitting this into 8. As it has 8 min terms, right? So we're splitting this into 8. We're splitting this into 2, splitting into 4, splitting into 6, splitting into 8. Okay, so let's see. So as it is 3 variable, we can mention it A, B, C or even as A, B, C. Anything is fine. You can take it. So this will be fixed as one variable. If we fill it means 0, 1. So here there is one thing that we have to follow, that all the bit change happening when it is more than one bit means that need to be sequential, or it need to be there should be only one bit change like a binary gray code. So like 0 0, there need to be only one bit change, that is 1. So next you may think as 1 0. If you use 1 0, then this bit also changing, this bit also changing. So that is not allowed in K-map diagram. So how we can do is that we can take 1 1 next and then 1 0. Here if you see there is only one bit change and here there is only one bit change. So this is one term rules that we have to follow here. Here also 0 0 0 1 1 1 1 0. So this is one very important rule, you guys have to remember it. As we know, rest of things is same as it is m1 m0 m1 sorry m2 m3 m6 m7. Here only m4 because 100 is 4, m5. So here also same m0 m1 m2 m3 m4 m5 m6 and m7. Okay, so this is what. So let's see how we can minimize the function. So let's get into 4 level K-map. So our 3 level K-map itself fine. So let's take an example how we can do it. For example, a comma b comma c, which is equal to the summation of min terms, that is 0 comma 2 comma 3 comma 6 comma 7. So if they are giving like this, how we can find and minimize? Why I am saying minimized is when we use a K-map, the output will be generally minimized. So if we represent this in the expanded format, what will we think is that a bar, b bar, c bar. So this is how it will be. Then this two will be represented as 1 0 0. So a bar, b, c bar plus 3 can be represented as 0 1 1. So that will be a bar b c plus 6 can be represented as 1 0 1 1 0. So that will be a b c bar plus 7 will be represented as a b c. So this is the actual expanded full logical function. But let's see after doing K-map how our function is get to smallest thing. So let me explain it. So let's take the thing. So let's split this into 2, 4, 6. I am suggesting all to try and then watch my answer. Please pause the video and try to answer it. Okay. So let me take this one A, B, C. So here we know 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So the thing is that at the 0 we have to put 1 and at the 2 we have to put 1, that is here, and at the 3 we have to put 1, so that is here. 2 is here, 3 is here, and then 6 and then 7. Okay. So now we know how we can group the things. So we know the top priority that can be make here is the 4. So here there is a 4 adjacency is formed. So we can group all these 4 together. So next thing is that this one can form adjacency with this one. Axis is we need to consider this as cyclic. So we should not make this as a single. So this one can be mapped to this one. So this can be mapped like this. So this will be mapped like this. So this let me draw in another one curve. Okay, so this can map like this. So here we are having two things. So one is red color, one is blue color. So how we can minimize the red thing is that in red color this two is varying, so we have to skip it. So even in this one, the first variable is only constant. So the varying two thing we have to remove it. So here this f can be written as only b. So red color resulting in only b. So now plus now the blue color term. So blue color term as a bar is the constant thing, and in a bar and also b is constant. So we can write as a bar b. Okay. So this is what the simple thing that we have to do here. I think it is a bar plus b. Yes, correct. As it is b only, because this is only not a varying thing. So this is a bar plus b. So from this one we can clearly see that this b is only not changing. So we have write that a b here, and then with this two thing we can clearly say the a is constant. So that we have a bar is constant. We have mentioned a bar, and this one I think I missed this one 0 0 and 1 0. So this is the thing. So I made a mistake here. Please make a note of it. So this is a bar. So a bar is fixed, and here I consider this two one. So this should not be considered. So this one here, if you see c bar and c bar is only constant. So a bar, c bar. So this is what the correct logic. Okay. So let me give you one more thing so that you guys can't confuse. You guys may uh, solve it carefully. So let me take a function, right? F is equal to, so f is equal to a comma b comma c. So which is equal to summation m of 1 comma 3 comma 6 comma 7. Okay, so let me draw a k-map. So this will be very if you guys understand it, then you can enjoy the k-map thing. So if you guys haven't understood, please watch this carefully. So easily we can score marks here. Even in gate examination, college semester, any kind of things, we can easily score marks here. Okay, so here it is a, here it is bc. So 0 1 0 0 0 1 1 1 1 0. Okay, so in last thing I made a mistake here, so please make a note of it, that we have to compare this two element. Okay, first I made it, then I corrected it. So as a bar is constant and c bar is constant, so that thing we have made it, so don't confuse that one. Okay, so here let's take this example. So please pause the video and try to answer it, then come to here. So we know 1 is drawn here, and 2 3 is made here, 4 5 6 and 7. Okay, so let's start the grouping here. So let's take red color for this one. So what we can do, so 2 is the priority, right? So we can map this one. So this is one more ping and blue. So even we can map like this one. This is one mapping, and then even we can map like this. But if you see, the blue color is redundant here. So blue color is redundant. Blue is redundant. So even that is not needed. So even if we remove that blue can, then also all the implicants will be covered. So we won't consider blue here. So only red and things. The function which will be equal to. So from the red one, if we take the thing, the red, if you know, that is a bar, and this term. So this two constant term is c. So c plus. So blue is removed. So yellow is the thing. So yellow we can take that is a, and from this one b is constant. So ab. So this is what the logic function that we are able to get from the logic. So I hope you guys able to understand, right? So I think 3 variable k-map and 2 variable k-map you guys have a quite good idea. So let me show how we can draw a 4 variable k-map. So this will be the limit. After that we can skip it, because in a college semester or even in a gate examination they will ask up to only 4 variable k-map. So nothing, 4 will also same. We have to make a 16 implicants there. So we have split it into 2, split it into 4, like similar to 3 variable, draw it, and then we have to separate even the y-axis. So 16, that's what, simple, right? So here simple, AB CD 4 variable, 0 0 0 1 1 1 1 0, right? So 0 0 0 1 1 1 1 0. Okay, so here it is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Okay, so this is how we can represent the min terms. Okay, so let's see how we can group or minimize the 4 variable k maps. So let me quickly draw one 4 variable k map, or even shall I use this one, because it will reduce the time, right? So let me use this one itself. Okay, so let's see what the function has. So let me directly draw some random functions. So 1 1 1 1 and here 1. Okay, so this is the function that they given. So try to draw the k map, like find the simplified Boolean algebra from here. So I'm giving this to you. Pause the video and try to answer, then see the answer. So as we know, the priority is 4, so I am taking the middle one, 4 here. So that's the first one. So and then another 4 possibilities also there, you guys may miss it. So the corner one, so all the corners is also mapped together. So adjacency means this also. When we fold this k map, what are the variables that is intersecting that we can take into group? So if we fold this one, this 2 2 will map here. We fold this one, this 1 1, this 2 will also map here. So that's what we're mentioning. So here we see this only one which is pending here. So this one we can do like anything. So even we can map like this one, or even you can map this with anything. So even if you can try this one, or even with the yellow one, you can try to map this like this one. Anyone is your wish, but we have to consider this at only one. So I'm taking to green. So I'm skipping, like I'm doing like this way. Okay. So if you do it, then the function which will be equal to. So first let me write the red one. So red one, if you see here, the constant thing is b. So b is the constant. So if we consider this one, the b is the constant. So b is the constant here. If we consider this two, here d is constant. So bd. Right. So next blue one plus. If we consider in the blue one, so this two row 0 0 1 0. So b bar is constant. So b bar, and this one 0 0 1 d, 0 is constant. That is d bar. Okay. Plus now the green one. So green one is this one. So this one the 0 1 which is constant. So before that here from the FTC, a bar is constant. So a bar and this one which is c bar d. So c bar d. So you see 1 2 3 4 5 6 7 8 9. So 9 min terms are now written very shortly. So 9 terms are now written in just 3 Boolean things. So this is what the minimized answer. This is the best minimized answer. This is the best minimized answers. So that we can get only from K-map. So K-map will always give only minimized. Hereafter we no need to minimize anything. So only minimized. So okay. So that is what the specialty of the K-map. So I hope this is fine from this lecture. So in the next lecture, I will be teaching you some more things like how we can draw. Let me complete this one also, like a 5 variable K-map. So I will know. I will show how to draw only. So how we can draw is that just it is in 2 box. So like this way we have to draw. The thing is that there is only one thing. So we have to take one variable outside, a which is equal to 0, a which is equal to 1. And here we have to draw BC, DE and BC, DE. So actually, as you see, this one cannot be imagined that much nice. So that's why we usually won't go for 5 variable K maps in our semester examination or even GATE examination. So thing is the here the same. That is a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 will come. Here will come 16 because here if you see 0, 0. So this is 1 0 0 0. So that will come here. So that is 1 0 0 0. So it means it's 1 2 4 8 16, right? So 16 will start from here. So that is what the quite difference. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. Okay. So here we need to fill it 0 0 0 1 1 1 1 0. So 0 0 0 1 1 1 1 0. So 0 0 0 1 1 1 1 0. So 0 0 0 1 1 1 1 0. So this is what. So this will be quite difficult for us to term. So this is I won't get into that thing. So that thing we can skip it directly. So that one we can remove it. Don't worry about this thing. So from next lecture, I will be giving you another one important concept, that is how we can find out the implicant, prime implicant, and essential prime implicant. So this is the last topic. From this, we can conclude our K-map discussion, and then we can move to other things like we can start with our combinational circuit lectures. So there we will be seeing the adders, subtractor, multipliers, and those kind of logics will be there. So there you guys able to understand a lot of more concepts in digital electronics. So stay tuned guys. We can see in the next lecture. Thank you.